Good morning, Year 6. This week in Maths, we'll be looking at ratio. Whoa, calm down. You only need multiplication knowledge. Right, chill.
Ratio is a useful tool for comparing things to each other in mathematics and real life. It's a comparison of two or more numbers that indicate their sizes in relation to each other. Look, Lego. That's not scary. So I'm going to write the ratio for the bricks you see in front of you. We say for every 3 red, there is 1 blue. Here there are 4 parts in total. 3 red parts, 1 blue part. With ratio you can even compare more than 2 sets of objects. Here, for every 3 red bricks, there are 2 blue bricks and 1 white brick. So for every 3 red, there are 2 blue and 1 white. The colon separates the ratio every time. See, that's not too bad, is it? There is a snag though. Let's have a look at this one. So for every 4 red, there are 2 blue. Now, the problem with this is that ratios must be expressed in as simple terms as possible. So these can actually be grouped like so. Let's rearrange those. Now, as you can see, we can split our ratio in half. For every 2 red, there are 1 blue. Now, if you don't have any Lego bricks, this can be simply done using multiplication facts. Here's a simple example. For every 6 red bricks, there are 2 blue bricks. So we want to do this using our times table knowledge. Now this can be simplified pretty easily. I know that a common factor of 2 and 6 is 2. They're both in the 2 times table. So all you have to do is ask how many 2's go into 6? 3 of them. And then how many 2's go into 2? 1 of them. This is exactly the same as a ratio of 3 to 1. This can be proven by rearranging my Lego bricks. For every 3 reds, there's 1 blue. Just like that. See, that's not too scary, is it?
So press pause now and have a go at simplifying these ratios in your own time.
Okay, right, 18 to 2. I know for a fact that they're both in the 2 times table. So I ask, how many 2's go into 2? 1 of them. And how many 2's go into 18? 9 of them. So 18 for every 2 is actually 9 to 1, a ratio of 9 to 1. In the next one, this one looks a little bit more difficult because they're bigger, but really, they're both in the 10 times table. So I ask, how many 10's go into 10? 1 of them. How many 10's go into 70? 7 of them. That ratio is actually 7 to 1. Simplifying the final one, when I look at this, I straight away see the 3 times table. See what I mean? Times table knowledge is massive when we're doing ratio. How many 3's go into 3? 1 of them. How many 3's go into 21? There are 7. Look, those two are equal.
Using your knowledge of simplifying ratios, can you spot the odd one out? Press pause now.
So the odd one out then. Let's simplify all the ratios you see in front of you. So 9 to 3, it's in the 3 times table. How many 3's go into 3? 1. How many 3's go into 9? 3. 3 to 1. 18 to 6. Again, it's a 3 times table, isn't it? So, how many 3's go into 6? 2 of them. How many 3's go into 18? Well, that would be 6 of them. However, I'm not done yet with this one because it can be simplified further. So now I have a look. What times table are these in? Well, it's the 2 times table now. So to further simplify, I ask, how many 2's go into 2? 1 of them. And how many 2's go into 6? 3 of them. It's 3 to 1 again. This one is 3 to 1. So let's just check the last one. 5 times table this time. So I'd ask, how many 5's go into 5? Oops, nearly put 5 then. One of them. And how many 5s go into 20? 4 of them. So that's a ratio of 4 to 1. So the odd one out, 20 to 5.
See, that's not so bad, is it? Great, so let's look at an example. This is question 2 of the My Maths task you'll have to complete after this video. I'm going to take you through how to do this, looking at particular examples. We're going to be using the noughts and crosses style ratio method. First up, what happens if there are 3 blue beads? How many black beads are there? What are the total number of beads? Here's how you do it.
First, try your noughts and crosses grid. Now, at the top, we write our headings. Blue beads, black beads, total. Now, the original ratio is that for every 1 blue bead, there are 7 black beads, means a total of 8. Then, the box we were wanting to fill in was what happens when there are 3 blue beads. You simply have to work out what you multiplied 1 by to get 3, which is pretty simple, it's 3. So we do the same to all of the other boxes. So, if there are 3 blue beads, the amount of black beads is 7 times 3, 21. That means that the total will be 8 times 3, 24. You can check this because 3 add 21 equals 24. So that's how I would fill those in.
These are what the answers would look like transferred to the table, scruffily. Next up, if there are 42 black beads, how many blue beads does that mean there are? And how many beads in total?
We go back to the same grid. Now this time we know how many black beads there are in the sequence we're given. It says there's 42 of them. So then what we have to do is work out how we got to 42 from 7. Well, we would need, knowing your times tables, as we said, important, 6 lots of 7 black beads to get to 42. So again, we do the same to the rest. 6 times 8 is 48. We just check along the bottom. Is 6 blue beads add 42 black beads, a total of 48 beads? It is indeed.
And there's the answers transferred to the table. Final example, pinky promise. What if we know the total amount of beads, but we don't know how many blue or black there are?
Same grid. This time we know the total number of beads in our sequence is 88. So that allows us to work out how many blue and how many black there are. We just need to work out what you multiply 8 to get to 88. Again, if you're on Times Table Rockstars very regularly, you'll know that 8 times 11 is 88. That means you have to do 7 times 11 and 1 times 11, which is 11 and 77. And that is how many blue and black beads there are if there are 88 beads in total. Not too hard.
And there it is in the table. So log on to My Maths and give that a go. Good luck.